Hello friends, welcome you all. I'm Arun, going to deliver a short lecture on engineering materials part 2. In this lecture, we will discuss various heat treatment processes used for steels. Friends, in the previous lecture, we learned that how engineering materials are classified. Also, we seen that how the engineering materials exhibit different type of properties including mechanical, electrical and thermal properties. We highlighted and defined a few of the properties related with mechanical field. Friends, after completing this lecture, you should be able to learn that what is heat treatment process, what are the different heat treatment processes which are used in mechanical engineering. The processes included are normalizing, annealing, hardening and tempering. Then after completing this lecture, you should also be able to explain widely used ferrous alloys like wrought iron, cast iron, stainless steel, and high speed steel. Now, let us learn about heat treatment process. Heat treatment process is used to produce the required properties in carbon steel. Friends, we have learned various mechanical properties in the previous lecture, such as the strength of material, toughness, its ductility, and many other properties. So with the help of heat treatment process, we get the variation in these properties with the help of this heat treatment process. In heat treatment process, we carry out heating or chilling, normally to extreme temperatures, to achieve the desired result, such as hardening or softening of carbon steel. So in heat treatment, we will see that there will be heating normally at high temperatures and consequent chilling. Why heat treatment process get the variation in the properties of a material? The reason is polymorphism of iron that enable it to heat treat these carbon alloys. So what is polymorphism? Polymorphism is the transformation in the structure of iron from FCC to BCC or vice versa, and that occurs at different temperatures. So in nutshell, because of the property of polymorphism of iron, when we do heating and chilling of iron alloy or carbon steel alloy, we get the variation in required properties, and we do it for the sake of the required amount of properties for a particular application. In the set of heat treatment processes, let us first take normalizing process. The purpose of normalizing is to free the steel from any locked up stresses. What do you mean by locked up stresses? Let me tell you that while manufacturing different type of products, when we carry out certain manufacturing processes which require hammering or putting high amount of forces, then what happens that some amount of these forces get locked up inside the material, and we call it as locked up stresses. In normalizing, what we do, we first heat up a piece of steel to just above its upper critical temperature, and then we allow it to attain a uniform temperature throughout. We spend some time so that the material can get the uniform temperature throughout its structure, deep inside and in every at every nook and corner of the product. Then we withdraw it from the furnace and allow it to cool to room temperature in still air. So remember friends, in case of normalizing, the heating is above the upper critical temperature, number one. Number two, we spend some time so that the material can get heated up and we get the same temperature throughout. Third point, we get it cooled, but the cooling is done to room temperature in still air. That means the product or the job piece is removed from the furnace and then we get the cooling. This heating and slow cooling alters the microstructure of the metal, and which in turn reduces its hardness and increases its ductility. So friends, the purpose of normalizing too is to free the steel from locked up stresses as well as to get reduction in its hardness and increment in its ductility. For example, when we do forging, the job piece get hammered for a certain time period, and after getting the desired shape of the job piece, we know there would be some locked up stresses, and that's why this forged job piece is normalized. The next heat treatment process is annealing. Annealing is carried out in order to remove all casting stresses and the brittleness. Friends, you know, many of the products are just casted. That means the metal is molten by doing its heating to its melting point, and then this molten metal is poured in the mold and we get the desired shape, and this desired shape of the product is what we call as casting. And during casting, since the metal is in molten state, so it is at very high temperature and there will be solidification thereafter the casting is carried out. So during this cooling process, there might be some stresses remain inside the body of that product and there will be some brittleness. So the annealing is done so as to remove all these casting related stresses and brittleness. The process of annealing is very similar to normalizing process. That means again it is heated above the upper critical temperature. It is kept at that temperature so that we can get the same temperature throughout its body. However, the cooling is carried out within the furnace. Friends, remember, the cooling is done inside the furnace. In case of normalizing, we remove the job piece from the furnace and then we get the cooling in room air. But in case of annealing, the cooling is done within the furnace. The job piece remain inside the furnace. So the rate of cooling is lesser as compared to normalizing. It achieves slightly less ductility and slightly higher hardness when compared to normalizing process. So it takes more time comparatively. Now let us discuss the remaining heat treatment processes. So the third process is hardening. Friends, in the previous lecture you learned that how we defined the hardness of a material. So here hardening is a process by which we improve the hardness of steel, and the process for hardening includes heating of a piece of job just above its upper critical temperature and followed by quick cooling. Friends, again you need to notice that in case of normalizing, the cooling was in the still air of the room. In case of annealing, the cooling was done inside the furnace, And here, in case of hardening process, we carry out the cooling quickly. I mean, we take very small amount of time to get the job piece cooled, and for that reason we require some cooling medium. So for cooling or quenching, we use water or oil, and in this way the job piece get increment in its hardness significantly. The fourth process is tempering. So what is tempering? In case of hardening process, since we carried out this quenching process in water or oil, so it was quite rapid, and because of that there would be some amount of brittleness developed inside the material. And for removal of this brittleness of a fully hardened carbon steel, and there are some quenching stresses also during this hardening process, so its removal is done by using this process of tempering. So the aim of tempering is to remove brittleness and quenching stresses that we got during the hardening process. The process of tempering includes reheating or tempering the quenched component so that the stresses are relieved and brittleness and extreme hardness is reduced. Friends, here we concluded 4 important heat treatment processes, and now let us discuss about some important ferrous alloys which are used in industries widely. The first one is wrought iron. Friends, wrought means possessing sufficient ductility. So it implies that the wrought iron is having high amount of ductility, and this ductility permit it to get hot or cold deformed. That means we have two type of forming processes, hot forming and cold forming, and for having this forming process done easily, we need to have that material to possess sufficient amount of ductility. So wrought iron are easily hot and cold deformed. Wrought iron is the purest form of iron, remember it. The typical composition indicates 99% of iron and traces of carbon and other impurities. So you can see, out of all the set of ferrous alloys, so the purest one is wrought iron. It is very tough, malleable and ductile. Friends, you have learned toughness, malleability, ductility in the previous lecture. The typical products made up of wrought iron are crane hook. Yes friends, the crane hook which you notice while using a crane, which is used to hold the heavy loads, is made up of wrought iron. The railway couplings, bolts and nuts, chains, barbed wire, coal handling equipment, and many more applications are there for this kind of ferrous alloy, that is the wrought iron. The next important one is cast iron. Cast iron, as I already explained you, contains 2 to 4% of carbon. The melting point of cast iron is much lower than that of the steel. Please notice this point, that cast iron get melted at comparatively lower temperature as in case of steels. So the properties like easy casting, low cost, its high compressive strength, its good wear resistance, and its excellent machinability make it very useful in engineering application. So friends, please notice that cast iron is having easy casting property. Since its melting point is low, so it will be highly its liquidity is quite high, and the cost is low comparatively, and it is having high compressive strength, good wear resistance and excellent machinability, and that's why it is widely used in engineering applications. But remember, it is brittle and having low tensile strength. So in those applications where tensile force is applied on a job piece, we do not use cast iron, and it is brittle also. It is used in manufacturing machine tool bodies, automobile cylinder blocks, flywheels, etc. Yes, friends, the lathe you might have seen in your machine shop and many other machine tools, their bodies are made up of cast iron. And in the previous time, the cylinder blocks of an automobile engine is also made up of cast iron. Nowadays, aluminum alloys are used for this application. The third important ferrous alloy is stainless steel. You all are aware of it. It is called stainless steel because it do not corrode or rust easily in most of the environment and media, and that's why we call it stainless steel. It contains the important alloying elements are chromium, manganese, silicon, apart from, besides carbon. Carbon is already there, but in addition to carbon, chromium, manganese and silicon are also present in stainless steel. And a popular stainless steel called 18:8 stainless steel is the steel that include 18% of chromium. Please notice the significant amount of chromium in this stainless steel, 18%, and 8% nickel, and plus other alloying elements are also there. The main application of stainless steel is it is used in products such as table cutlery, tubes and equipments, springs, ball bearings, etc. And in this series of ferrous alloy, one of the important alloy is high speed steel, which is widely used for cutting tool applications. It can cut steel at high cutting speeds. So when we do this cutting operation at high speed, the cutting tool which we use are made up of this type of material, that is high speed steel. It is designed for high strength, high impact toughness and high wear resistance, not only at room temperature but also at elevated temperatures. It is having excellent hardenability. It remains hard even at 650 degrees Celsius temperature, since we use them for cutting the job pieces. So during this cutting operation we get very high temperature at the contact point, and since the temperature is high, even then the high speed steel does not lose its hardness, and it is because of its excellent hardenability property. It contains relatively large amount of tungsten, molybdenum together with chromium, cobalt and vanadium. So friends, please notice that high speed steel, because of the inclusion of tungsten and molybdenum and together with chromium and cobalt and vanadium, it gets these desirable properties. So here we are going to conclude our lecture. Thank you. Another point, it is used to produce cutting tools for turning, drilling, milling operations also.